we'll do that. Um, so as I mentioned to Susan, I'm not like, there's other things I could wax eloquent about for a long time. Clearly, I think you saw that yesterday. This one is not one of the things that I have tons of experience doing. So I hope that the folks that are in the room that have more experience than I do will chip in on some of this evaluation. So first of all, I do want to get you familiar with these forms. There's a couple of, let me plop the link to the GTR in the chat here. And so this is the composite burn index evaluation. There's also a soil burn severity evaluation form. Now, this composite burn index is, like we talked about yesterday with standard protocols, there's reasons to do something because it's been done. And so composite burn index, it's possible that there could be improvements with that, but it's also then an established method and it's got some consistency to it. So it also then has that important correlation with satellite imagery. And maybe I want to look back just a little bit. How do people feel about the concept of are there any questions about how this information from satellite imagery is acquired or what that, like what's the process there? If anyone's curious about that, we can talk about that a little bit. Any questions from anyone there? I would also, by the way, love to see more of you. If you have like clothing on and a camera and could turn it on, that'd be great. Christine.
Yeah, my question was, like if we do a prescribed burn, how soon or, how can we get that composite burn index or either like a severity mapping or something to show for the post-fire effects, like maybe within, I don't know, maybe 30 or 60, 90 days that shows that reflectance of where all of the if we have any high severity burns in there that needs to be looked at by foresters stuff.
So you're talking about when you can get that data back from imagery, not just you doing it on the ground, right?
Yes, from imagery. Yeah.
Yeah.
We haven't done anything on the ground for the composite burn index. I like to try to use the one from imagery.
Yeah, so at any point you can do the composite burn index on the ground. And that's just a check off things. Now that when you tie this, so here's, I'm just gonna background you a little bit on satellite imagery and how this all works. From space, these satellites are looking at the Earth and they are picking up the energy that the Earth is bouncing back. When they pick that up, they are looking at a couple different places along this electromagnetic spectrum. There's information that's going up to space, and they're picking it up, and they're getting some numbers, and then we're like, I think it means this. And the truth is that, I mean, it's from space, and it's like pretty big resolution, 30 by 30 meter resolution on the ground for this particular satellite. So it's not perfect. What it relies on is us doing the composite burn index to say, at this point, the severity is 2.5 or whatever, some number. And then we train what the imagery is saying so that it knows that if it sees more of just like that all of that means that it's 2.5. So a good post-fire layer from satellite imagery is validated with ground data. Without that, then your breakpoints between what is low, what is, like you saw those images, what is low, what's moderate, what's high, the breakpoint between low, moderate, and high is all messed up. So when you go on to like the monitoring trends and burn severity site, MTBS, all of those have had some type of validation. Ideally, they've gone out, people have gone out and done some plots and then like made it just so that it wasn't this there's a product that's a rapid assessment of that, but then further refinement makes it closer. For your burn spots, this stuff is a little bit trickier. There's a lot of work that goes into making these post-fire maps, like the visually fancy ones. So at a minimum, you can do this with just your ground truth data. If you felt like you wanted a full map like she produced, then that would take some some GISing. I've got like a lab that people can follow if they feel like they want to try that out. One of the things that goes into that is taking imagery in the same type of growing season. So if, for example, if you took because when you're trying to do fire severity, you're taking an image before the fire and you're taking an image after the fire. The challenge with wildfires is they go on for so long that by the time the fire's ended, it's a whole different season. So you can't take just a pre and post fire like within the same year. So you have to take a pre image and then the next year you take the post image in that same time of year. It has to be cloudless days, so that can be challenging sometimes, especially in cloudier areas like West Coast Washington. And then you've got also just like natural variations in seasons that can account for some of the differences that are there. So another challenge of this is that when you talk about satellite imagery, it's got 30 by 30 meter resolution. If you've got a burn unit that is 20 acres, 30 acres, that's like 10 pixels or something. It's more than that, but it's not very many pixels. These maps that she was showing us are huge fires. So I think what I'm probably alluding to here is that doing imagery of composite burn index from these particular satellites might not be the product that you are trying to get to tell your story, but there is a lot of work being done with drones. So sending up drones in areas and then matching the drone imagery to your composite burn index stuff. Landsat's this satellite that does all this stuff from space. And so what the drone opportunity is to close that gap. And so what I've seen some studies happening about like looking at, how well it's able to predict mortality from trees or something. So those are some things to consider. I would say more immediate would be doing some plots and doing like in this certified burn or not certified burn, composite burn index method, and then even just taking aerial imagery and doing some images that way. But I don't see a whole lot of application, or perhaps the juice is not necessarily worth the squeeze for the GIS effort for smaller projects, unless you've got really large projects. How large are the projects that you're working on, Christine?
Um, most of them are close to 2,000 acres.
Okay.
And um, and I forgot that we recently had our reservation do the LiDAR, the
Yeah,
aerial LiDAR too. So that kind
yeah,
of came to mind when you mentioned about, drone and stuff. So if
yeah.
we do like the composite burn index on the ground, then we can um use the LiDAR with that too, the
Yeah,
mapping.
yeah, that's a great idea. And there's just a lot more that we're learning about LiDAR. LiDAR is super easy to collect and it's incredibly labor intensive to do anything with. So we're trying to figure that out still. Just the amount of data that comes from LiDAR of any kind it's a lot. And so what we're coming up against with the LiDAR is like, oh, great, we got all this LiDAR collected. And what's it mean? Well, I don't know, it's just a bunch of dots. Like it's hard to know what it means. And so, but we have to start there. We have to start with a bunch of data. And then we have to, and then the people will develop the skill to deal with it and to tell us the answers to these questions. Yeah.
Okay. Yeah.
But one of the things that the imagery does is it does tell important stories. MTBS, maybe someone knows better than I. The MTBS site, it is done for all fires over 1,000 acres, wildfires over 1,000 acres. Is that being done at all in prescribed fires that anyone knows? I wonder if that's an application that we should request. Like if there's some opportunity to say, hey, you've got all these perimeters from wildfires from your incident database. Here's a perimeter of our 2,000 acre prescribed fire. Could you add that to your evaluation? Because they're not doing this like one fire at a time, which is incredibly labor intensive. They're doing this as like an area. So could be some potential. You think they do both, Dana? Yeah, I've not looked recently, so that's something to potentially check out. Here's a small plug for like the accessibility of this information or like requesting. Sometimes we'll look at well, let's say we'll look at Susan or Duncan and you're like, oh, they made FFT or FFI. Wow, I could never talk to them about what I need. And that's like completely not true. They are absolutely 100% here to serve you. And MTBS is the same way. Like if there's a number on there, call them. They love to hear about people using their information. And if you run into an issue, tell them so that they can fix it. I feel like that's how I've gotten to know Duncan mostly. I'm like, Duncan, I'm stuck. I can't get this FFI thing to work. And that type of collaboration make these programs work for you. That's what they're supposed to do. So maybe that would be a good route, is to see what you don't have to do, but we can maybe just help get these other groups to help you do to tell that story better. Yeah. But I mean, regardless, something that, tying into yesterday's discussion, could all this advanced technology, we've got, AI potentially and LiDAR, terrestrial LiDAR and UAS LiDAR and satellite LiDAR and satellite imagery, and all of it's going to need to be ground truthed. And so you do still need to have that ground monitoring skill so that you can train those technologies so that they are producing results that make sense. It's a great question. Noah asks, anyone else tried using Planet Labs imagery 3 meter for processing? I have not. Limitations with normalized burn ratio, not possible with bands available. That's too bad. No, I've not. So it's got visual, it's got in the near infrared, but not the bands. So just this, a slight background here on this NBR, normalized burn ratio, is what that's standing for there. And as I mentioned, these satellite images, or satellites are gathering information from the Earth, and they gather it at certain parts along this electromagnetic spectrum where plants are particularly communicative. They're giving a lot of information. And so this normalized burn ratio is a special, not terribly difficult math equation that just says on these certain bands, 5 and 7, I think, or whatever they are, if there's a bigger difference here, and there's a bigger difference and a bigger change in vegetation. So in order for processing of change in vegetation, you need to have that imagery looking at the right pieces of energy along that spectrum. So we get a lot of visual estimates, like as you probably well know, you can look at Google Earth after a fire and you can see a little bit of red or whatever, but there's more information that's being given than is what we can see. There's information about tree stress, there's information about type of vegetation, even field moisture. That's something that's being developed, is abilities to collect live field moisture from imagery, which is huge because we just really don't know a lot about what live field moisture equates to what fire behavior. Okay, and we can take a look at this. I want to answer any other questions that are coming up through this discussion, or we can start to take a look at that CBI. Okay, yeah, I've got some good resource being shared. So within this GTR, let me hide my controls here. Okay, so in this GTR, there's a page down near the bottom. I guess it's in the middle. And I just want to get you familiar with what the types of things are that are being asked. And let me zoom in here. Okay. So what we're trying our best to do with plots like this is to anticipate long-term impacts. Um, One of the challenges with that is that there's a lot more that affects the impact from fire than just the fire. There's a lot has to do with the conditions before and after, even far after, that affect that long-term outcome. But there's things that we can see right away, and that's what this tends to ask. So let's just go through and familiarize yourself with the data sheet. Okay. So burn severity scale, first of all, goes from 0 to 3 with broader categories of low, moderate, and high. Um, as Susan mentioned, this can be challenging when you're talking about like what's the difference between a high and a grass or a high and a forest. It's a pretty big difference. So this isn't going to kind of vet that difference out necessarily. Litter and light fuels consumed. And so from an analysis standpoint, you look at that consumption. In fact, I think that it'd just be easier to go through this and look at my example at the same time. So let me pull up these 360-degree photos and we'll just flop back and forth between an example of a site that's burned and the question. Okay, so first, these are really cool 360-degree images. So there's like this circular camera. It's so neat. You just plop it in to these places and it takes this picture. So this is a site in California. So these were taken by Tim Yurkevich. He's in charge of the Fuels Academy. This would be another person to Monique to put down on your list of potential speakers for the future. So he is going out and using these cameras to take these images, and I use these in RX310 as kind of a backup plan if people don't have a site to go to. So let's use this spot as a good example. Okay, so our form, let me get to that one. Flipping here. Oh, I see. Open it in a new tab. Okay, so litter, light fuels consumed. So we've got unchanged, 50% litter consumed, 100% litter consumed, or let's see, greater than 80% of light fuels and 98% of light fuels. So this is, I think, assuming then that these light fuels are present still in these lower moderate places. So let's take a look at our area. And what I'm noticing is I see a little bit of an unburned spot right there. So it's skipped. Like at this particular spot, I'm seeing a mixture of mostly black, places of white, ash with the log that's like anywhere you can see where the sticks were, these little like well they call them like cigarette ash, like so you can see those from space pretty clearly. You can see where the sticks were on the ground and those are now consumed. We got a stick remaining here. This was clearly a log, and we've got some duff and litter left. Okay, so just exploring all around. I'm going to have you answer in the chat here what you think this value would be. So again, did that. The question is, give me a value in the chat for what level of burn severity we are at in this spot. Group consciousness, let's see what you got. What level you are answering. This is a question that you are answering for me. So put down in that chat, what do you think this site is for severity? 2.5, 2, 3. Moderate without seeing the canopy. Well, we're all just doing one piece at a time. We'll do all that collectively. So we'll just do this just for the light litter and fuels consumed. So 3. So we got 98% of light fuels consumed, greater than 80% of light fuels. See, already I'm judging this form because greater than 80%, isn't that 98% also?
Okay, I'm a little confused about how to use this form. Are we looking at like where are we putting those numbers? And like when you're looking at 50% litter or 100% litter,
Mhm.
I'm sorry, I'm confused. Like, do
So
we put
we would pick one of these. So it's either, and it's I'm not sure why the dash is there, but in the box over here with factor score, we would put the score um for this row only. For only
the,
this row.
s- the score 0 to 3?
The score, yep,
Okay.
0 to 3 in
So
increment.
then what is 50% then considered low?
Yes.
100% is good. Okay.
Yep. Yep.
Starting to
So
make
in
sense.
this
Got it.
column here, a 100%, and so then you could assume 75% consumption of litter would be your moderate scale. Um, Now, one of the things that Susan mentioned is that this is challenging because how much litter was there before? I don't know. I wasn't here before. So this would be a case for doing pre-monitoring so that you knew what that change was. You can make some assumptions, based on what's here, because there are some places, like I pointed out, that the litter remains, but it's possible. Okay, so let's look at this little lumpy spot here. Okay, so you can see there's like a fissure in there. That to me meant that there was a bigger pile of litter or duff. And so I could tell that in some of these places where the litter remains, like here, it just might have been a lighter load of litter, which is why it remained. So it is hard to tell what existed before. So you're making your best guess. Christine?
Yeah, I had a question, because on that form it says like, I think litter consumed that we're looking at right now, light
Yep.
litter or litter light fuel consumed. And I know we see all the white ash and I know all that is consumed, but there's also black char on the ground, but those are not consumed all the way. It may just be pine needles that are charred and it looks black. So do we count those as
Mm.
consumed or how do we count those?
I would count those as consumed. Again, if those other folks online have
Okay.
a better breakpoint for that. The reason that I would count them as consumed is because they have changed.
Okay.
Their chemistry has changed. They're gonna burn differently. If it burned again, for example, they wouldn't be as available. And probably more importantly, it is much easier to distinguish the line between unburned, like for sure, and kind of burned. So the line between like kind of burned and really burned is a lot fuzzier of a line and would be harder to distinguish for people between that line. So I would say on this patch here, that's my unburned patch. And everything else I'd call burned. One of the little side techniques that I'll use sometimes, like in burning, especially prescribed fire, when you're burning on like lower ends of your prescription or it's wetter, cooler ends of your prescription. Sometimes our objective is like burn 50% of an area or something. And so I devised this a couple years ago and it works pretty well. So if I wanted to burn 50% of an area, then I'd take my crew and I'd stretch them out and I give them, I'll have a piece of paper and a tally and they just walk and they just tally every time they step. Every time their right foot steps on black or not black. And so they're just like how many like unblack, black, not black, like burned, unburned, burned, unburned. So then by the end of their transect, they have a total number of steps, which is, let's say, 100. And then they had 75 that landed into black. If I have enough people walking through an area, then I can do the math on like roughly what area burned. It's a pretty like rudimentary way to assess area burned, but it gives you something. Okay, so I think that we're averaging around a 2.5. So we're thinking greater than 80% of light fuels, less than 98% of light fuels burned. And I think that's coming from the couple patches that we've got left. There's also what we would probably see if we dug into this a little bit is that in some of those places where it just really skimmed off the surface, there's probably some depth of litter that's not been burned there. What I see more often is that the litter will burn off, but the duff will remain. So who knows? We'll just say that there's some litter there. So I think 2.5 is a reasonable number for that. Okay, 2.5 there. Duff, light char, 50% loss, deep char, or fully consumed. So give me some estimates just based on what you see here. And here's maybe a tip that I'll give you is if it's black, the duff probably remains. If it's white, the duff is likely gone. So let's just cruise around here, seeing those areas that are black, considering that they would still have duff, and considering the areas that have any white char on them would have 0 duff. So what do we think for the index for duff? So 50% loss, deep char, 2, 2. Okay, so we're feeling like we're at a 2. So we put a 2 there. I wonder if I can do some. Why is it so big? Whatever, it'll do. Okay, well, that's 2.5. All right, so then the next one, fuel, medium fuels, 3 to 8 inches. So these are our 100-hour plus. Yeah, go ahead, Christine.
Just looking at that, your 360 picture from that center, I guess if there's a plot there at the center, how I guess how far from that plot center are we measuring or estimating these CBI?
Oh, it's a great question. Now within CBI, you'll have a whole plot system just like you would in your pre-fire measurement. So I don't know what the protocols were, let's say that Susan used for the CBI, but what I often do is I go with my macro plot area, my 10-meter area, and I'm doing that. I mean, right now we're doing this qualitatively. We're not like, being really specific and measuring exactly how much is covering. So we're kind of just doing within our sight of what this is. Now that might be enough to get a general value. And we're doing actually a pretty decent job at the moment. But exactly how you do this within, I think the video covers that. Oh, hey, Susan. Will you answer that question? What size of plot do you typically do for your CBIs?
Christine goes first, so why don't you go for it?
Oh, no, she asked the question.
Oh, sorry, missed your name. Sorry about that. So we actually tried to do 30-meter area to represent a pixel. And that said, we only allowed ourselves to be in a patch of uniform pixels so that we were representing a broader patch and not just one pixel of high severity where we could be halfway in, halfway out. And so that worked pretty well for us to think about a 30-meter area, like square or circular area. So that sounds really similar to what you're doing, Heather, just with this 10-meter. Yeah.
And within that 30-meter area, are you like walking around and like getting kind of like
Yeah.
the
Yeah. And then the other thing we did, and this was really helpful for us, is think through, why are we collecting this index? What is our purpose for this study? And our purpose was heavy on the trees, right? And so, yeah, we did due diligence on everything that Heather's stepping us through right now. And Heather's probably a better guide than me at this point because it's been so long. But honestly, Alina Kanzler took all of our tree mortality and scorch data and converted our tree data into CBI, and it worked out really well. So for our study, CBI was more informative for tree mortality. And so we were biased towards the tree effects.
Got it. Yeah. Yeah. So again, just like yesterday, it all comes back to what your objectives are, and sampling, whatever you're sampling, do that, like focusing in on the things that you're most curious about. If you're really concerned with erosion and runoff stuff, then getting that duff and litter is really important. But if you're focused on mortality, then spending that time, the extra time on the trees would be important as well. Good question.
Heather, the top of the form, Carl and Nate suggested a 30-meter diameter. It's in the form there, 30-meter diameter.
Percent burn 100 feet, 30-meter diameter from center of the plot. Yeah, that's great. So
I rely on Duncan to keep me honest a lot. So
keep
That's a
You
mistake.
passed the test this time. You remembered correctly the font size. Now, something that Susan said is important here in that when you are looking at do I have a quick spot for this? I do have a quick spot for this. Let me just get a visual here of, let's see, this is in the, I want to just emphasize to you the size of this pixel thing is important. Okay, so this is some older version of a presentation for 390 that we're working on, but the I've got it in here. Oh, there it is. Okay. So when you are looking at Landsat imagery, which is what picks up a lot of this stuff, you're dealing with this 30 by 30 meter resolution pixel. So on the ground, this whole square here is equals this one square. So what Susan mentioned there is you want to go for an area that's not just 30 by 30 meters all the same, but you want to measure in an area that's like bigger than that so that it's being picked up on. So if I was looking at land fire imagery, then I would, or Landsat imagery, I would want to sample in this big green area because I'm in the middle of the stuff that the satellite thinks is all the same. And so, anyway, that's just a like, you don't want necessarily to go and look for the minute example of like a random spot that just torched out, because that's not going to be picked up by the satellite imagery.
I'm going to chime in just there too, because one of the things we were thinking about, especially with highly pixelated cells, is that especially if you're in like low to moderate, that reflectance is affected by the neighborhood with the satellite. And so it's really kind of like you're less certain on a 1 pixel anomaly than you are with a bigger patch. Kind of just saying what you said, Heather, but in terms of what the satellite also is detecting.
Yeah, definitely. Okay. Let's get through a couple other of these. So we'll just consider these all the same here for a second. So we've got medium fuel 3 to 8.
Can I just pause for just a second? Sorry, Heather. I just want to make sure, Duncan, you're okay with the timing on this in your presentation next, because we just bumped it a little bit. So I know that we're like friends here. So I just want to make sure before we keep going. Is that okay?
Yep, I'm good with it.
Okay.
Thanks for checking.
Awesome. Thanks so much. Continue on.
Okay. And we're not going to go through each of these and pick a value. I think that we were able to kind of work out how that picking works. So just to draw attention to the fuel consumption, that's pretty straightforward. Soil and rock cover color. Any thoughts on that one? I'm not sure what they, like if you're changing the soil condition, if it's maybe going from like aggregated to powdery or something. I'd probably do that of just like, how is this soil changing? Again, if soil was the thing that was big for you, which it may not be. Yeah, Monique.
So I know there might be some soil experts in here, so they probably already know this, but I had learned that, the rocks and stones actually protect the roots of a lot of different plants, and so they reduce the impact of fire on especially like cultural plants or when you're planting or replanting after a fire. And so I was curious, like Heather or Duncan or Susan, if you think that this represents that, do you think that this would take into account if you're looking at fire severity, say in a huckleberry patch, and then you went and looked at it one season post fire, it had a whole bunch of rocks, but those areas, so it was Rebecca Pion with the Colville tribes did a study and ended up finding out that some of these areas that they thought were high severity, which were still high severity, ended up actually, because of the rocks, ended up seeing regrowth and a lot more huckleberries than they expected. So some of these things we don't expect, I guess. I was curious about your thoughts on that.
Is it okay if I chime in, or do you want to take this, Heather?
Go for it. I'll pull up an image that explains soil and vegetation severity.
Yeah, I love that you mentioned Rebecca Pion. She's just so practiced, Monique, and just has so much place-based knowledge about fire effects. So a couple things that I've heard, I'm a little bit more book smart than I would like to be on this, but one is that dry mineral soil, much like a dry hot pad, really insulates roots better than actually moist soil. And so if you imagine getting your hot pad accidentally wet, it can conduct heat and you're like, ouch, but if it's dry, it doesn't. Same thing with soil. And so Monique, when Rebecca was noticing that the rocky soils were insulating roots, that totally jives with what I've learned. So ironically, if you have deep, moist duff layers that bake for a long time, that can be really hard on root systems. And so looking at a big change in mineral soil might not be your perfect indication of how much roots are affected. So there's that. I will say that for this severity, what we were walking through a lot in the tripod area were some sections where the soil actually has this class to it, this hydrophobic crust. And we felt like that was really changed from fire. And then when that crust broke, it's just like moon dust. And so the soil texture and color were really changed. And so that's when we marked that one really high for us. Helen.
Sorry, I have a different question. I don't want to change this subject if we're still going on.
I'll just add into that last thought that there's the soil burn severity assessment that gets more into the soil impacts that you could explore. Go ahead, Helen.
I guess maybe that was a little bit of a segue to my question, because I wanted to ask about the use of this CBI assessment versus like an RX 310. I think like you kept pulling up and we saw in the background is that the soil burn severity from I think it's Bayer, right? Yeah. And so when should you use one over the other? Because I remember trying to choose the different protocols for us and seeing that this is like a landscape level assessment. So like, well, maybe I should go for something that's a little bit simpler. So I guess if you could speak into maybe like when you'd use one versus the other.
I do not know. Susan, Duncan.
I would just say, if you're looking at something on a small project scale, thing, that I would tend to look at plot scale assessments rather than using composite burn index, which is really meant to calibrate satellite imagery. And I like CBI, but if you can just use something in a smaller scale, I think that's good for project scale work.
I find this to be a little more accessible than CBI because it has these descriptors on it, and so you can kind of like, oh, is my tree canopy largely unaltered? Yeah, so it's, to me, it is a little bit easier to get that ground level assessment. What is this GTR? Is this from? Oh, GTR 243. Yeah. Well, I think we can stop it there for now and maybe take a quick break. And I don't know, what do you think there, Autumn?
I think we will have Duncan present on his because this just all goes together so well, and he's on the schedule for right now, and then we'll take a break after that if we're all good with that.
Yep.
It was so great to meet with all of you. I have to go officially now, but yeah, great to see everyone.
Thanks for hopping back on, Susan. That was great.
Bye, Susan.
Thank you, Susan.
Okay, bye.
Bye.
One other thing, Heather, I'll just mention real quick with the CBI is that there are codes in the description. If you have something that you're not interested in or you can't make an assessment, you can use like a -1 or -2, -3, and then that will be ignored in the CBI rating when it comes out to calculate it. So if the point is that if you run into something you just don't know, you can use one of those other codes. You don't have to rate everything. All right, here we go. Let me see.